Hello children, welcome back to the digital class. I hope you are all doing well. So today you might be excited to learn some new concepts in this session. Let us start our session now. Look at our India map, children. Do you know what is the population of our country? Yes. According to 2011 census, the population of our country is 120 crores. You can see the number written over on your screen, right? Now, doesn't it a huge number, children? Yes. You can see a dark sky overnight, right? Here is the moon shining brightly. Oh, our earth is also there here. Children, do you know the distance between moon and earth? So, if you notice, the distance between moon and the earth is 3,84,400 kilometers. Can you imagine the distance, children? Such a huge distance, isn't it? Now take a look at the sun shining brightly, and the sun rays reaches our earth in a certain time. Do you know what is the speed of these light rays? Yes, the speed of light in vacuum is about 30 crore meters per second. Such a huge number, right children? Children, let us summarize what we have seen. Do you know how to represent these large numbers in a simpler manner? Yes. So, in today's topic, that is powers and exponents, we are going to study about it. By the end of this session, you will learn exponents, laws of exponents, and also you will learn large numbers in standard form. Take a look at the numbers shown on your screen, children. So, you have 3 plus 3 plus 3 plus 3, and also you have 10 added 6 times. Do you know what is this called as, children? Yes, repeated addition, which is nothing but multiplication. Now, what do you write this, children? Yes, since 3 is added 4 times, we write it as 4 times 3. Now, whereas if you consider this place, 10 is added 6 times, so we write 6 times 10, isn't it, children? Yes. But children, do you know how to express this repeated multiplication in a simple way? That is, if you are going to multiply 10 6 times, now how will you write this? Yes, we are going to write it as shown on your screen. Now, let us learn about this type of numbers or expressing this type of numbers. Now, here we have seen just now the number shown. This type of numbers are said to be in exponential form, and here this 10 is called the base and 6 is called the exponent. And do you know, children, how do we read this number? Yes, we read it as 10 raised to the power of 6, or in short we even read it as 10 to the power of 6. Okay, children. Now, children, can you tell me the exponential form of this number? It is 5 raised to the power of 6, because here 5 is multiplied 6 times. Now, let us see another example, 9 into 9. So, here 9 repeated 2 times. So, we write it as 9 raised to the power of 2. And children, this 9 raised to the power of 2 is also read as 9 squared. Okay, children, we call it as squared whenever the power is 2. Now, let us take another example, 7 multiplied 3 times, we write it as 7 raised to the power of 3. Now, this 7 raised to the power of 3 is also read as 7 cubed. Now, let us take an example to find out which exponential number is greater, that is 3 to the power of 5 or 5 to the power of 3, which is greater among these two. So, children, 3 to the power of 5 means 3 multiplied 5 times, right. Now, let us multiply these numbers, children. So, 3 into 3, 9, again 9 into 3, 27, 27 into 3, 81, 81 into 3, 243. Okay, children. So, we get 243. Now, what about 5 to the power of 3 or 5 cubed, children? Yes, 5 multiplied 3 times. On multiplying 5 3 times, we get 125. Now, children, out of these two numbers, which is greater? Yes, it is 243 greater than 125. But what is 243 children? Yes, it is 3 to the power of 5. And what about 125 children? It is 5 to the power of 3, which means I can write 3 to the power of 5 is greater than 5 to the power of 3. Okay, children. So, children, this is how we compare any two exponential numbers. Okay, children. Now, let us move on to our next time. Now, children, here a multiplied by a, what do we get? Yes, a square. Now, I am multiplying a 3 times. So, we get a cube. Now, let us multiply a 4 times, we get a to the power of 4. Now, children, I want a to the power of 5. Then now tell me how many times we need to multiply a? You are right once again. We need to multiply a 5 times. So, if we go on multiplying like this, I am multiplying a m number of times, where m can be any integer. I can take it as m as 100 times, or I can take m as 50 times or 200 times, or whatever it is. M can take any positive value. Okay, children. Now, in that case, what will be the exponential form of this number? Let us see. We get a to the power of m. But why? If you notice, here 2 times we multiplied, so power is 2. 3 times multiplied, power 3. 4 times multiplied, 4. 5 times multiplied, here we have 5. Like that, when we are multiplying m times, so what should be the exponent of a, children? Yes, it should be m. So, we get a to the power of m. I hope you understood the concept clearly, children. Okay? Let us move on to the next concept. Here in a to the power of m, a is called the base and m is called the exponent. Now, let us learn how to express the numbers in exponential form. Now, for that we have prime factorization method. Let us take an example. So, we are going to express 360 into product of prime factors. Children, I think you know what are prime numbers, right? Which has only 2 factors. They are called prime numbers, right? For example, you can take 2, 3, 5, 7, 11, so on. These are all prime numbers. So, now we are going to express 360 as a product of these prime numbers. Okay? Now, let us see how to do that. Now, first we will divide this 360 with the first prime number. Now, is 360 divisible by 2, children? Yes, 360 we can easily divide with 2. So, how much you get? 180. That means, I can write 360 as 2 into 180. Now, again 180 is divisible by 2. So, now let us divide 180 with 2. How much you get, children? Yes, 90. That means, I can write this 180 as 2 into 90. Now, this 2 remains as it is and 180 is written as 2 into 90. Now, let us see again, we will divide 90 with 2. So, how much you get, children? Yes, we get 45. Again, this 90 is written as 2 into 45 and 2 into 2 as it is remains same, no change. Now, let us see the division of 45. Is it divisible by 2, children? No, it is an odd number, right? Now, we will go for the next prime number. What is the next prime number, children? Yes, it is 3. Now, let us divide with 3. Now, it goes 15 times. That means, I can write now 45 as 3 into 15 and these 3 2's remain same. Now, again this 15 is divisible by 3. Now, let us divide with that. How much did you get, children? Yes, 5. Again this 15 is written as 3 into 5. Now, let us finally divide with 5, children. Only 5 is left, right? So, the next prime number is 5. It goes how many times, children? Only 1 time. Now, we got the product of all these primes, but they are not in exponential form, children. So, we need to express in exponential form only. Okay? Now, let us see how to write these product of primes into exponential form. Now, take a look at this, children. Yes. How many 2's are there? There are 3 2's. That means, 2 into 2 into 2, it can be written as 2 to the power of 3. Right, children? Then, if you notice, there are how many 3's, children? Yes, there are 2 3's. That is 3 into 3. So, we can write it as 3 square. And at last, we have only 1 5. So, we write 5 to the power of 1. Now, this 2 cube into 3 square into 5 to the power of 1 is nothing but the product of prime factors in exponential form. So, I hope, children, you might have understood how to express a given number as a product of prime factors, okay, in exponential form. Okay, children. Now, let us move on to another concept. So, now we are going to learn about laws of exponents, children. So, consider 3 power 3 into 3 square. Now, what is 3 power 3, children? Yes, I can write this as product of 3 times, that is 3 into 3 into 3. So, we have multiplied 3 times, isn't it? Now, what about 3 square, children? Yes, since the power is 2, we multiply 2 times. So, total how many are there, children? Yes, we have 5 3's. If you notice here 3 and here we have 2, total 3 plus 2, that is 5. So, if I see the product of all these 5 numbers, that is 3 into 3 into 3 into 3 into up to 5 times, this can be written as, yes, 3 to the power of 5. That means, I can write 3 to the power of 3 into 3 square as 3 to the power of 5. Now, 5, can I write it as 3 plus 2, children? Yes, I can write it. So, this I will write it as 3 to the power of 3 plus 2. So, let us summarize, children, and try to find a rule satisfying the given expression. Okay, children, let us see. Now, suppose if I have 8 to the power of 5 into 8 to the power of 4, now using the above relation, how do you write this, children? Yes, if you notice here we have seen 3 to the power of 3 into 3 square is 3 to the power of 3 plus 2, right? We just added the powers, and if you notice the bases are same. Here also the bases are same. So, what we need to do, children? Yes, we need to just add the powers, that is 8 to the power of 5 plus 4, which is nothing but 8 to the power of 9. So, this is true for all such type of exponents, children. So, if I have 8 to the power of m into 8 to the power of n, now can you guess, children, what do we get? Yes, absolutely right. It is 8 to the power of m plus n. Now, this is our first law of exponent, which states for any non-zero integer a, and whereas m and n are integers, then a to the power of m into a to the power of n is equal to a to the power of m plus n. Now, this is known as multiplying terms with the same base. Okay? Why we call it as multiplying terms with the same bases? Now, these are the two terms we are multiplying and having the same bases. Then we have the same base, but only the powers need to be added, m plus n. Now, let us move on to our next law of exponent. So, this is about exponent of exponent. Now, consider 5 square whole cube. Now, what do you mean by this, children? 5 square whole cube means 5 square is multiplied 3 times. So, within brackets we have 5 square, that means this particular thing is multiplied 3 times, 5 square into 5 square into 5 square. We have already learnt in the previous formula, that is a power m into a power n is a to the power of m plus n. Now, this is true for any number of product of expressions, children. Like for example, if you have a power m into a power n into a to the power of some p, then you get a to the power of m plus n plus p. So, here also we have product of 3 terms. Now, we will add all those exponents like 2 plus 2 plus 2. So, we get 5 to the power of 2 plus 2 plus 2. Now, what do you get, children? Yes, 5 to the power of 6. Hence, I can write 5 square whole cube is nothing but 5 to the power of 2 into 3, because 6 can also be written as 2 into 3. But why are we writing 2 into 3? Because in LHS also we have powers 2 and 3. So, that is why we are expressing in terms of these two only. Now, based on this result, I will give you an example. Now, 10 to the power of 4 whole to the power of 5. Now, can you tell me, children, what do you get? Yes, 10 to the power of 20. Why? Because we need to just multiply this exponent, that is 4 into 5. So, 10 to the power of 20. So, the base whatever is here, it remains same here 10, only we need to add the powers, that is 4 into 5 gives us 20. Okay, children. Now, let us take a to the power of m whole to the power of n. Then what do you get, children? Yes, we simply get a to the power of m into n. M into n is nothing but mn. Now, this is our second law, that is exponent of an exponent. So, for any non-zero integer a and mn are integers, we write a power m whole power n is equal to a to the power of mn, which is nothing but a to the power of m into n. Okay, children. Now, let us move on to the next one, exponent of a product. Now, consider 2 to the power of 3 into 5 to the power of 3. So, we can write 2 to the power of 3 as, yes, 2 into 2 into 2. Now, what about 5 to the power of 3, children? Yes, we write it as 5 multiplied 3 times. Now, let us rearrange them. Yes, I am rearranging it as 2 into 5 into 2 into 5 into 2 into 5, because here we have 3, here also we have 3. So, I am making this as one group and these two as another group and the remaining as another group. So, you got now 2 into 5 as 3 groups. So, can I write it as 2 into 5 whole cube, children, because this entire thing is repeated 3 times. So, I am taking it as power 3. So, what do you conclude, children, from this? Yes, 2 power 3 into 5 power 3 is 2 into 5 whole power 3. So, this is our next law, which states for any non-zero integers a, b and m is any positive integer, then a to the power of m into b to the power of m is equal to a into b whole power m. Okay, children. Now, let us move on to our next law, that is division of exponent. So, for any non-zero integer a and any integer n, a power minus n is always equal to 1 by a to the power of n. Let us see one example. So, 3 power minus 4. So, I can express this as 1 by 3 to the power of 4. So, 1 by 3 raised to the power of 4, that means what, children? 3 is multiplied 4 times. So, in the denominator we are multiplying 3 4 times. How much you get, children? 3 into 3 9, 9 3 is 27, 27 into 3 81. So, you get 1 by 81. Next, zero exponents. Let us see what is zero exponent. For any non-zero integer a power 0 is always 1. That means you take any non-zero integer, like for example, I am taking here 6 power 0, it is 1. I take 2 power 0, that is also 1. 1 to the power of 0, that is also 1. You take any non-zero integer, children. So, when it is raised to the power of 0, it is always equal to 1. Now, let us see division of exponents having the same pace. That is, for any non-zero integer a and m and n are integers, a power m by a power n is always equal to a power m minus n. This is true for m greater than n. So, this is very important, children. We use this one only when m is greater than n, whereas a power m by a power n is 1 by a to the power of n minus m when m is less than n. So, you need to be very careful, children, whether m is greater than n or n is greater than m. Now, let us take an example for this. 4 to the power of 5 divided by 4 to the power of 3. Now, if you see here, m is 5, n is 3, that means m is greater than n. So, we are going to use the first one. So, we get the base 4 and power should be subtracted 5 minus 3, 4 to the power of 5 minus 3, which is, so that gives 4 square. Okay, children. Let us move on to our next law, dividing terms with the same exponents. So, for any non-zero integers a, b and m is an integer, a by b whole power m is equal to a power m by b power m. Let us take an example. 2 by 3 whole power 4 can be written as 2 to the power of 4 by 3 to the power of 4. Okay, children. So, next one, further you can simplify 2 power 4 as 16 and 3 power 4 is 81. So, we can write it as 16 by 81, children. Now, let us take one important note, children. So, we have seen the different laws of exponents, okay, children, and also we learned what is an exponent. Now, let us take some important concepts that we need to remember, okay, children. So, 1 square is written as 1 into 1. Now, what do you get, children? Yes, we get 1. Now, what about 1 cube? 1 into 1 into 1. Again, what do you get, children? Yes, you get again 1. Now, 1 to the power of 4. So, we are multiplying 1 4 times, you still get 1 only. That means, 1 to the power of 8 if I take, you get 1 only. 1 to the power of 100 also if I take, I get 1 only. Now, then what do you conclude from this, children? Yes, 1 raised to any power is 1. That is 1 raised to the power of, you take it as say some 50 or 1000, still you get 1 only. Okay, children. Now, let us see the next point. So, minus 1 whole square can be written as minus 1 into minus 1. So, what do you get, children? Minus 1 into minus 1? Yes. So, minus into minus, it will be plus. 1 into 1 we have already seen it is 1. So, you get plus 1. Now, let us take minus 1 cube. So, 1 into 1 into 1, minus into minus, plus, again plus into minus, we get minus. So, we get minus 1. Now, let us take minus 1 whole power 4, that is minus 1 is multiplied 4 times. So, minus into minus plus, plus into minus minus, minus into again minus plus. 1 4 times we get 1, means the value is 1. Now, let us take minus 1 whole to the power of 5 children. Now, if you multiply, you get it as minus 1. Now, what do you conclude from these children? Let us see. If I have minus 1 whole to the power of 10, what do you get? We get 1. But why? If you notice, here power is 2, we got 1. Here power is 4, you got 1. That means power is 2, 4 and so on. If you write, they are all even numbers, then the value you are getting is plus 1, right children. So, that is why minus 1 whole to the power of 10 is plus 1. Now, what about minus 1 whole to the power of 11? You got minus 1. Why? If you notice, minus 1 whole cube means power is odd, you are getting minus 1. So, what do you conclude children from this? Yes, minus 1 raised to even power is always plus 1 and minus 1 raised to odd power is always minus 1. Okay, children. Not only that children, we can generalize this to any other numbers also. Let us see. Minus a whole power m is equal to a to the power of m if m is even. Similarly, minus a whole power m is equal to minus a power m if m is odd. Let us solve one small example children, that is express minus 8 by 27 in exponential form. So, minus 8, this can be written as product of minus 2 and minus 2. Okay, children. So, what do you get? Minus into minus, we have plus, plus into minus, minus. 2 into 2, 4, 4 into 2, 8. So, we get minus 2 whole cube, right children. Then 27, this can be written as 3 into 3 into 3. Since it is positive, I am taking all 3 as positive integers. So, you get 3 multiplied 3 times, so you get 3 cube. So, now minus 8 by 27 can be written as minus 2 whole cube by 3 cube. Now, children, we have seen one law of exponent which states a by b whole power m is equal to a power m by b power m. So, here we have this part. Now, this can be written as a by b whole power m. That means, this particular thing can be written as minus 2 by 3 whole power 3. So, this negative sign, I mean to this 2 also, it does not make any difference children. Okay, children. So, children, till now we have learnt exponents and also laws of exponents and we have seen few examples also. Now, let us learn how to express large numbers in their standard form. Okay, children, let us see. Now, we have already seen children the population of our country, right. It is 120 crores according to 2011 census. Now, we write this expression in standard form or it is also known as scientific notation or form. What do you mean by that? A number which is expressed as the product of largest integer exponent of 10 and a decimal number which is between 1 and 10. That means, always we have to express this as exponent of 10, 10 to the power of something should be there and the other number which we are going to take should be in between 1 and 10. So, let us understand this children. I will write this 120 crores as C, 12 into 10 to the power of 8. How could we write this? Let us see, count the number of zeros, 3, 4, 5, 6, 7, 8. So, I write this as 10 to the power of 8 because we have 10 zeros after this digit 12. Okay. Now, suppose if there is a number over here, you should not count the total number of zeros. After a particular digit other than 0, how many numbers are there? That only you need to count. So, after 2 we have 8 zeros. So, I am writing it as 10 to the power of 8. Then what is left children? 12. So, I am writing 12. But the second part is it should be a decimal number between 1 and 10. Now, this is more than 10. So, that means it is not in standard form. Now, to make it in standard form, this has to be converted to what? A decimal number between 1 and 10. Now, for that what I will do is I will put a decimal point between 1 and 2. So, between 1 and 2 I marked a decimal point. Now, after decimal point how many digits are there children? Yes, we have only one digit. So, since only one digit is there, the power of this 10 increases by 1 because we have one digit only after the decimal point. So, previously it is 8, now it will become 9 because after decimal point we have only one digit. Now, this is said to be in standard form. Why it is said to be in standard form children? If you notice, 1.2 is in between 1 and 10 and it is into 10 to the power of some integer. Okay, children. Now, let us take one more example also, that is the distance between the moon and the earth, that is around 3,84,400 kilometers. Now, let us write this in standard form. So, here if you notice, there are only 2 zeros after this digit 4. So, 10 square, because there are 2 zeros, and the remaining number is 3844. But this is a very big number, right? Still 3844. This number should be in between 1 and 10. So, where should I put the decimal point, children? Yes, in between 3 and 8. So, I will put that. I get 3.844 into, after the decimal point, how many digits are there, children? 1, 2, 3. So, the power of 10 should increase by 3. So, already there is 2. So, we are increasing by another 3. So, 2 plus 3. So, it should be 5. Now, this number is said to be in the standard form. Okay, children. So, the distance between moon and earth is written as 3.844 into 10 to the power of 5 kilometers. Till now, in this session, we have learnt what are exponents, what is meant by base, exponent, and also we have learnt the laws of exponents with few examples. Not only that, even we have expressed large numbers in standard form. Now, let us apply these concepts in solving few examples. Let us start with our first problem. If a equal to 3, b equal to 2, find the value of a power b plus b power a. That is our first bit. Second bit is a power a plus b power b whole to the power of minus 1. Let us start with the solution. So, in this we are going to substitute simply the values of a and b. So, a power b, a is 3. So, substituted a is 3, and here the power is b, that is b value is 2. So, I am writing power 2 plus b is 2. So, 2 raised to the power of a, that is 3. So, we get 3 square plus 2 cube. Now, what is 3 square, children? Yes, 3 into 3, which is 9. And what about 2 cube, children? 2 into 2 into 2, which is 8. Now, substitute these values. We get 9 plus 8. How much you get, children? 17. So, it is a very simple example, right, children? Now, let us solve the second one. Now, again we are substituting the values of a and b. A is 3. So, 3 raised to the power of 3. B is 2. 2 raised to the power of 2 whole power minus 1. Again 3 power 3. 3 into 3 into 3, 27, 2 square, 2 into 2, which is 4. Now, substitute these values, children. We get 27 plus 4 whole to the power of minus 1. Now, what is 27 plus 4, children? Yes, 31 whole to the power of minus 1. Children, we have learned one laws of exponent, that is a power minus n is 1 by a to the power of n. So, 31 whole to the power of minus 1 can be written as, yes, 1 by 31. I hope you understood the problem. Let us move on to our next problem. Express the following as the product of prime factors. Let us see the first one, that is 600. So, we take the first prime numbers, that is 2. On dividing 600 with 2, we get 300. So, this can be written as 2 into 300, which is equal to 600. Now, again we divide 300 with 2. What do you get, children? Yes, 150. So, again, so this can be written as 2 into 150. Then again on dividing this with 2, we get 75, that is 2 into 75, and dividing with 3, we get 25, and further dividing we get as shown on your screen. Okay, children. How many 2's are there, children? 3, right? So, that means 2 to the power of 3 into how many 3's are there? 1. So, 3 power 1 into how many 5's are there, children? 2. So, we get 5 square. Okay, children. Now, let us move on to our next problem, that is 2520. So, let us express this in the form of prime factors. So, as shown on your screen. So, we are expressing it dividing with 2, 3 and then with 5 and finally with 7. So, on dividing this you got all these things, children. Now, here 2 is multiplied 3 times. So, I get 2 cube into 3 is multiplied 2 times. I get 3 square. Again 5 only 1 is there. So, 5 power 1 into 7 is there only 1. So, we get 7 power 1. Okay, children. So, this is how we express in prime factors. Okay, children. Children, we have learnt few examples also. Now, let us see before winding off the session the few concepts that we have already learnt. Very large numbers are easy to read, write, understand when expressed in exponential form. Okay, children. A multiplied m times gives a power m, and a to the power of m into a to the power of n is a to the power of m plus n. Again a power m whole power n is a power m n. Repeat, a power m into b power m is a b whole power m. A to the power of minus n is 1 by a power n. A power 0 is 1. Similarly, a power m by a power n is a power m minus n. a power m by a power n is 1 by a power n minus m. Then a by b whole power m is a power m by b power m. So, 1 raised to any power is 1 and minus 1 raised to odd power is minus 1 and minus 1 raised to even power is always plus 1. So, in standard form a number is expressed as a product of large integer exponent of 10 and a decimal number between 1 and 10. So, children, till now we have seen the exponents, the laws of exponents and expressing large numbers in the standard form, and we have done few examples also, and I have given some problems to work out, children. Please do it and show to your teacher. So, with this we come to the end of our session, children. I hope you have understood the concepts clearly. Till then, we meet in our next class. Goodbye and take care.